Elliott Athletics is trying to determine its optimal capital structure, which now consists of only debt and common equity. The firm does not currently use preferred stock in its capital structure, and it does not plan to do so in the future. Its treasury staff has consulted with investment bankers. On the basis of those discussions, the staff has created the following table. So now we can look at the debt here, the debt to assets, equity to assets, debt to equity. So at zero debt, no debt to our assets, at zero debt, you'll need to construct a table just like this. Our equity to assets in this case is zero debt. When we have zero debt, we're 100% use our equities to assets. So our equities to assets are 1. Our debt to equity ratio then would be 0. And our bond rating here at this time is an A bond rating. And our before tax cost of debt, also known as RD, is 7%. Now you know as you can see as the debt to assets go to, as we have 20% or 0.2% debt to assets and 80% or 0.8% of equity to assets, or debt to equity ratio, which is in this case is our debt to asset ratio divided by our equity to asset ratio equals 0.25. Our bond rating here is BBB, and our before tax debt is 8%. So you'll notice as the bond rating goes down, the cost of debt goes up. We have things like liquidity premium, default risk involved in this. Okay, Elliott also, so you need to make a chart just like this that it has in the book. Elliott uses a capital asset pricing model to estimate its cost of common equity, and it estimates that the real risk-free rate is 5%, market risk premium is 6%, and tax rate is 40%. It says its unlevered beta is 1.2. So what's the firm's optimal capital structure? You need to make your inputs like this: a risk-free rate, market risk premium, unlevered beta, and tax rate. Now we're going to use the Hamadeh equation, which is we'll find our levered beta equals the unlevered beta times 1 plus 1 minus the tax rate times our debt to equity ratio. So what we'll do is we'll bring down these from the table above, just like what we did. Just bring them down from the table above. You can see this is A15. It was just brought down. Same thing here. 1 minus A50. It's just you can either bring it down or do it like this, either way. And then have our debt to equity ratio. Now, to find our after-tax cost of debt, all we have to do to find our after-tax cost of debt is to find our before-tax cost of debt, which in this case, at this equity to asset or debt to equity ratio, our before-tax cost of debt was 7%. And just multiply that times 1 minus, in this case it's C35, or 40%. That's our after-tax cost of debt. Now we have to find our levered beta. And in that case, we just use the Hamadeh equation. So we find our levered beta, which is our unlevered beta here, C34 times 1 plus 1 minus the tax rate, all times our after-tax, our debt to equity ratio. And so in this case, our levered beta is 1.2. Now you just do that for each one of these. And then next we'll find, now that we have our levered beta, we'll find our cost of equity. And all we have to do to find our cost of equity is our risk-free rate plus, or RRF, plus our market risk. And we can find our cost of equity. Now we can find our weighted average cost of capital. We say our debt to asset ratio, which is 0 times our after-tax cost of debt plus our equity to asset ratio times our cost of equity, which would be right here, would be 50, to get 12.2 in this case. And we can run a minimum function, which we did here, and told it to look in this column and find the minimum weighted average cost of capital, which we can all look and see it's 11.45, and our debt to asset ratio at that case is 40. So we're 40%. Our best optimal capital structure would be 40% debt, 60% equity, and in that case, our weighted average cost of capital will be 11.45% because we want to have the cheapest we can. So that's our optimal capital structure. Our money's going to cost us less at 40% debt and 60% equity. Now, then be sure and answer the questions. Then do a graph, plot a graph of after-tax cost of debt, cost of equity, and weighted average cost of capital versus the debt to asset ratio and debt to equity ratio. So here we have our cost of capital here, our percentage of cost of capital, and here we have our debt to assets, and here we have our debt to equity. This was our various cost of capital. So here you can see our cost of equity here goes up as our equity increases, our assets increase, our percentage of assets increase, and here you can see our cost of equity, and you can see our cost of weighted average cost of capital, and our cost of after-tax cost of debt. Do one for each one, and let's see, that's it. Good luck. Have fun. Don't wait till the last minute.